Greetings of the day, students. We are going to discuss one of the major issues or the applications with respect to edge computing. So in the previous classes we have gone with certain basic things with respect to edge computing. What are the various applications, how edge computing is different from that of the cloud computing, and what are the challenges with respect to cloud computing that has made to evolve the concept of the edge computing. So in today's class we are going to deal with system modeling and research challenges. So system modeling, that means how well we could carry out the changes with respect to these edge devices, and what are the various research challenges. Definitely in any field, when we talk about there are certain challenges that emerge as the applications are going to be carried out in further fields. So if you observe anywhere any technology that develops at the first time, so as it grows on, so definitely at the dwindling stages of the technology, if we observe, there might be certain small challenges, but as the technology takes the boost up and many other people when they like and want to try that technology, so more and more challenges arises. Okay, when these challenges need to be addressed at a particular time, okay, that means what, when there is a need, we have to address these challenges. If these challenges are being addressed at the required time, when there is more demand from the end users, so definitely for such kind of technology or such kind of application there is a huge response, and the application grows in an exponential manner. In the similar way, so while utilizing the concepts of the edge computing, so there also arises certain sort of research challenges. So what are they? We'll have a look in detail about them. So if we are going to have a look, we could categorize, though there are many challenges. When we talk about the miscellaneous challenges, we could categorize them into two categories. What are they? Resource challenges and modeling challenges. Okay, so the challenges that we are facing with respect to the edge computing concept, they could be categorized into many types. So we are discussing in this session with respect to the miscellaneous challenges. Okay, so that doesn't come under a particular category, but still they exist. So we could classify them, these kinds of challenges, into two major categories. What are they? One is resource based challenges, another one is modeling based challenges. So when we talk about the resources, so what are the challenges that need to be addressed with respect to these edge computing that are coming from the resources? So deployment of the edge node. So here, in order to utilize the edge computing applications, so definitely we need to first deploy the edge resources. With respect to these edge resources, we need to deploy the edge nodes. Okay, so edge nodes are very important in order to make the data to transfer from one place to another place, as well as to collect the data. So that is also one of the deployment of the edge node. So until and unless there is a successful deployment of the edge node, we could not carry out the successful applications which could be delivered freely, or the data could be accessed, or with respect to any sort of response time. Okay, the next challenge that comes under with respect to resource category is nothing but that is a unified architecture to deal with heterogeneity. So heterogeneity means what? Different, see, homogeneity means same category, heterogeneity means different things. So in different scenarios, it would be better considered if we are having a unique architecture. Okay, so that simple architecture could address a lot of problems. Suppose there is a model, okay, that could address many challenges. So for every challenge we cannot address with respect to only one model. Okay, for example, you want to design a particular vehicle, let it be a car. So what is your first motto? You are going to design the car. Okay, that means what, the outlook of the design should be very good. If the outlook is good and the car is not giving mileage, is that good? No. So what is the other feature that you are going to add? So you are going to create an engine such that it should give more mileage. So at the time, so these are the two features that you are adding for the same model. So as further you go on, that means you want to add more and more things into the same model. That means for every challenge that you arise, you should not go for a different model. Okay, so whenever you are designing with respect to edge computing concept, there should exist a unique architecture, so that addresses many challenges. Okay, so that could carry out many solutions, that could provide many solutions which could deal with heterogeneity. So not only with the same kind of environment, so the architecture that has been developed or evolved, it should challenge any kind of working environment. It is not like that your edge device is going to give excellent result when there is no load, or the load is at the moderate rate. When there is a heavy load on your device, you are unable to get the results with respect to good quality. It's not like that. Okay, there should be a unique architecture that need to address with respect to different sort of challenges with respect to heterogeneity environment. Next, public usability of the edge nodes. So definitely, if the edge node is kept at a place where there is a more mobility of the end users, so at that time what do we observe? More amount of data need to be transacted, more amount of data need to be transferred, it should be collected. So all these kinds of things should be carried out within a short span of time. For example, consider when there are no trains at a railway station, what do we observe? The kind of people gathering at that particular place is very less. When the trains are being in the station, what do we observe? Many people are gathered at the place. So that means what? The services which are provided by these devices should carry out the service levels at a high quality. It is not like that for a few people only it is going to deliver good services. When the load is more, it is going to deliver not that means without quality services. It should not be like that. So public usability of the edge nodes. So public usability, the particular areas should be identified where more public or more end users are being attracted to the, or more end users are utilizing the services of the edge computing. So that is also a big challenge. Okay, next, interoperability with future communication networks. Interoperability. So what is the concept of the interoperability? Whatever may be the environment, okay, your defined thing should work in a correct way. Okay, interoperability. So working in different nature with same output, same kind of quality output. That concept is nothing but called as interoperability. So here what happens, when we are in the today's scenario, tomorrow today if we talk about we are still in our country that need to be full-fledged involved with 5G services. But if we compare the developed countries, okay, they are utilizing high generation services. Okay, so there what do we observe? Though the technology is at higher level, but the usage of the technology at different places is different. Okay, still there are certain remote areas where digital devices are not being accessed, even people are not aware of the mobile phones. Okay, so it could not be a great thing that if we show the mobile phone to such kind of people, they could be amazed. So here what happens? Interoperability with the future communication network. So today we are going to utilize 5G. Tomorrow with various requirements, with various challenges, what do we observe? In tomorrow's scenario, there may be a need of another kind of technology. So at that time, the particular services, the architecture that we have developed, it should not be completely changed. Okay, if you are adding a new, if you you are getting a new challenge, that should be added to the present architecture. Okay, so that is nothing but interoperability with the future communication network. So whatever the thing that you are developing with respect to the concept of the edge computing with respect to architecture, that should need to address the future communication networks. Okay, it is not like that only you are finding a solution for the present scenario. Okay, your solution that you are finding for a particular scenario here should be addressing the coming challenges also. So that is nothing but the future communication network. Next, adjusting networking slices for edge computing. So there is an important term that we have to make sure here is nothing but the concept of the networking slices. So what is the concept of the networking slices? When we talk about IoT devices or edge devices, so there are with our eyes we see only physical network, okay, that is very limited, but these physical networks are connected to n number of virtual networks, okay. So there must be a certain thing that connects okay, the communication between all these virtual networks on a standard physical network. That concept is nothing but called as networking slices, okay. So as we go on with the coming days, what do we observe? The usage of the IoT devices, the usage of wireless things, they are going to be carried out more and more. So compare yourself when you are or 2 or 3 years back, if you observe, so the usage of the smart watches by many people was not in the present scenario. So if you observe the present scenario, usage of the smart devices or with respect to lot of IoT devices, they are being connected to humans or other things. So due to which what happens, more and more lots, an enormous amount of data is generated that need to be analyzed. So here the sources to collect the data, the sources to transfer the data to the next level, so such kind of devices are going to increase in an exponential order. So due to which what happens, there should be if a network that should manage. So everywhere we could not carry out the physical networks. So at that time we need to carry out the virtualized networks, okay. So there might be n number of virtual networks, okay. So these virtual networks should be connected to a standard physical device, okay. So standard physical network. So this network that means the capability of the physical network to handle these enormous virtual networks, the concept is nothing but called as networking slices for edge computing. So if we talk about the resources, these are the various challenges. Deployment, where to deploy the edge node, the correct place should be identified. Next, unified architectures, that means for every challenge we should not move to a new architecture, okay. There should be a standard architecture that is capable of addressing lot of challenges, okay. Next, public usability of the edge nodes. So we as the awareness among the end users are growing day by day, so more number of edge devices need to be deployed at various places. Next, interoperability, as we have discussed clearly, interoperability means to give the same kind of results at any kind of scenario. It is not like that when the workload is less we are getting excellent and quality of services, when the workload is very heavy we are not getting the quality and the services are not going smoothly, okay. Workload heavy means more number of users are connected, okay. So in that scenario. So next, network slices, okay. So as the coming days in the future we have to develop more and more virtualize networks which are going to connect lot of IoT devices and the edge devices. So those should be managed with the available physical networking concepts, okay. So that is the challenge, okay. Next, another way of challenging is nothing but the modeling. So when we talk about the modeling, so edge computing devices they are being deployed at various places with respect to geographical location, with respect to people's density, with respect to transfer of data, whether we, within a short span of time we need to transfer more bandwidth of data. So if you are going to observe such kind of scenarios, we have to develop the various kinds of modelings, okay. So with respect to modeling, these are the challenges. Demand modeling, that means what is the modeling which we could carry out with respect to the demand. Next, mobility modeling. Next, network resource modeling. Next, simulator efficiency. So simulators nowadays, simulators are playing a good vital role in order to get a complete scenario, okay. So let's have a look about these things in detail. So the research challenges. So when we talk about the scenario of the edge computing, within the main important thing that we observe here is nothing but the latency and various other services that need to be addressed. So for that we need 5 resource challenges. What are they? As the resource challenges as we have defined in the previous diagram, that is clearly. So these are the 5 resource challenges that need to be addressed. So here also we have specified the same. Next, when we talk about the modeling challenges, as we said, the edge devices services are being widened to mobile edge computing and mobile cloud computing. So not only edge applications are connected to next level edge applications. Edge applications are also connected to mobile applications. Edge applications are also connected to cloud applications. So the solution and the particular thing that is popping up is nothing but the architecture or the service delivery mode that we are developing. It should not be confined only to edge computing. It should further elongated and elaborated to mobile computing and mobile cloud computing or mobile edge computing. Okay, so the services, the applications that we are developing with respect to the core concept of the edge computing should not be limited to edge. They should be expanded towards mobile edge computing. They should be also expanded towards mobile cloud computing. So we are going to find a unique solution, a unique architecture that should have a capability to address n number of challenges, that should have the capability to work in a proper way, that is the interoperability. Okay, so for that we have to discuss about the various modeling challenges. So what are they? As we have discussed, demand modeling, mobility modeling, network modeling, simulator efficiency. So when we talk about the demand modeling, as the name itself suggests, okay, the demand on the edge resources. So definitely, as the due to the exponential growth of the technology, day by day what do we observe? Lot of devices are being generated which are capturing data, which are transferring data. So that makes a bit of thing in order to depending on the high grown demand, the lot of challenges, lot of things that need to be modified with respect to the demand modeling. Okay, the demand on the edge resources due to the individual user will need to be modeled. So definitely, when we talk about the architecture or the working nature of a particular edge device, with respect to one user it behaves in a different way, with respect to n users it behaves in a different way. So that means what, when one user is suppose the best example, consider you are sitting at a place where a router is there. The router is having certain bandwidth level. If you are sitting there as a alone person, you can download and transfer the data very well within short period of time. But if more number of people gathered and they are also utilizing the same sort of the router and they are connected to the free Wi-Fi, what do we observe? Slowly the speed, the download speed is being divided among the number of people there. So such kind of demands need to be which are arising, which demand that there should be a unique model that should work well. Okay, so like that. Next, mobility modeling. The need of mobility model arises in multiple cases. For example, you are considered, see, mobility modeling. See, mobility modeling means what? The edge computing devices or the applications need not be carried out for stable things. Suppose a human, suppose you want to monitor 24/7 medical reports of a patient. At that time, what happens? The particular patient may not be accompanied by any that means medical person. So at that time, you can connect the medical IoT devices to the person in order to note the blood pressure, to know the particular level of oxygen, to know the heartbeat rate. So that means what? Not only the person, we could carry out such kind of things when the person is not that means he is also moving, that means he could carry out his daily activities. At that time also we could monitor the services. It is not like that he should lay down or he should take the rest, okay, and all these medical parameters should be measured. It is not like that. So nowadays you observe smartwatches are there with every people. So they could carry out lot of things with that. They could know the heart rate, they could know the level of oxygen. Okay, so lot of things that they need to spend a different time in order to carry out such kind of activities. With a smartwatch they could carry out, but perfectly when we talk, definitely they are going to get certain sort of information, but we cannot say that that is accurate or whatever it may. That depends on the kind of the product they are wearing. Okay, so like that it may change. That is the mobility modeling. Okay, not only mobility modeling means not only stable. Okay, when the persons are in mobile nature also, they could utilize the services of the edge computing. Okay, so that is the concept. Next, network modeling. So as we are being familiar, when the edge resources are being deployed at a place where huge crowd or huge amount of data need to be segregated, huge amount of data need to be gathered, or that means we can deliver the data. So at that kind of thing, what do we observe? Suppose we want to transfer the data, or we need to connect to lot of virtual networks with respect to one physical network. At that time, what happens? We need there are different challenges that are coming with respect to the network. So those challenges could be carried out with respect to network modeling. Okay, the last one is nothing but the simulator efficiency. So simulators will need to be scalable, extensible to the changing infrastructure requirement and ease to use. So lot of simulators we observe. So generally simulators, why the simulators are being used to train, okay, for training purposes, most of the simulators to get the results, okay. So the things which could not be carried out at a real time could be carried out on a simulator to get a successful results. After getting them successfully, we can implement them in a real time scenario. So simulators, we should create a certain sort of simulators with respect to these edge computing concepts that could further work well. Okay, so that means what, not only with we have to develop these kinds of simulator efficiency with accurate results, not only considering the present scenario, for future scenario also we have to carry out such kind of things. Okay, thank you very much.